So you can think about the molecule which we are about to discuss. So this concept we are going to apply in a structure. So see, we have learned about it, right? Let us apply this idea into this structure. Fine. Apply it. Spreading, we learn about what is the meaning of spreading out. So now see, this is the molecule, and there are 9 types of sets of proton, therefore 9 signals. But our concern, our concentration, we are about to know about. Our aim is to learn about hydrogen shown in black, and we got an idea. This 5 member ring, protons will show 4 hertz value, and this 7 member ring will show 11 hertz, right? Fine. And yes, most important point is we learn here what is the meaning of this highest value for the which proton? Green proton. The highest value for green proton. So why? Question again, why? Why not for these any one of these protons? Fine. There's a question. Why this proton going at higher value? Why not these protons? So that is a question again.
Because
So yes, anyone from you? Yes.
two methyl group neighboring.
So अगर वो है तो that should goes to the, that is the electron donating groups क्या करते हैं, chemical shift decrease or increase? Yes, yes. Faiza,
डिक्रीज करते
they
डिक्रीज
decrease.
करते
They
इलेक्ट्रॉन।
decrease. Yes, they decrease the. See, if we go deep and deep, we will learn many things in spectroscopy and overall a molecule. We will learn about the spirit of molecule. We can say spirit of molecule. So, can you tell about this? Think about resonance, involve resonance concept, and you say why this is going to highest value. Why I am asking you? Because if you succeed to know about this high value, so we can judge that this proton for which, this signal for which proton, this proton. You can say theoretically also, no problem. आप बोलूंगी इस पर, you can say it कि ये जो प्रोटॉन है, suppose this number one, let us give number one here, and this let us give number two to this proton. So you will say this. What is this for? Can anyone say? This speaks for which proton? Doublet for one proton, two proton. Yes. Anyone? No. Yes. No one. Yes. Faiza, Adil. No answer. No. Fine. 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 Yes. Rubina. No.
नो सर।
Okay. Fine. Now listen. See here. See a very simple concept. See now. Why this is aromatic? Why this 7 member ring is aromatic? Can anyone tell?
सर
Yes. Yes.
प्लेनर स्ट्रक्चर एंड 6 pi electron which is
Very good.
obey
Very
the
good. Very good, very good. And that seven member ring having these 6 electrons. What about the seventh carbon? That will go by the positive charge. You are getting the point?
yes sir,
And have you heard about the tropylium cation?
yes sir.
So this carbon is a tertiary carbon, and that acquire the tropylium cation. Okay. But our reason is somewhat different. So now see this 7 member ring having creating this positive charge here after the resonance this pi electrons. So positive charge will shift across how many carbons? 7 carbons.
7
Yes, right. And so seven this circle completion takes place, and this H will acquire positive charge, right? Yes, after the resonance. And the most stable carbon will be this quaternary carbon which is near to this hydrogen. And we know tertiary carbon which acquire the positive charge. They are electron withdrawing groups or withdrawing center. Therefore, this carbon will acquire the positive. We can say tertiary carbon acquire the what positive sign while resonance, and therefore this withdraw electron, this H field, more electron, less electron density, more magnetic field, and hence goes to the higher value. Similarly, sometimes positive charge develop here, sometimes positive charge develop at this fused carbon, and therefore the value goes for this proton. Okay, fine. One more point I will tell you. Always remember, if you are unable to understand this concept in spectroscopy, but general idea is always remember the proton which is attached to the fused carbon, bridged carbon, or fused carbon in the ring, or carbon which is the common for the rings, the protons attached to them near the carbon, they always goes to the higher value. तो देखिए इसके लिए भी हायर वैल्यू है, ये दोनों के लिए भी क्या है, हायर वैल्यूज चला गया है. You got it? So this way you can also have this idea. Any proton which is near to the fused carbon goes to the higher value. So therefore, this is goes to the highest, and this goes to this one. Fine. So we understand this concept. Fine. So now see, there are nine signals, and they have given here the highest would be the singlet at 8.2 values, 8.2 hertz will be there. Fine. And so you can see here how the coupling will takes place. Just now we have seen. Fine. Sentence of the day. Sentence of the day. What is the sentence? Yes, read out this sentence. Electronegative atoms reduce coupling constant by withdrawing electron density from the bonds that transmit the coupling information. See, very, very beautiful sentence. Very beautiful sentence. What is the sentence? Sentence is very beautiful. Very much beautiful. See, what is the sentence of the day? Today's sentence. Electronegative atoms reduce coupling constant by withdrawing electron density from bonds that transmit the coupling information. So we can say J value is directly proportional to the extent of information, or we can say validity of information. जितना ज्यादा इंफॉर्मेशन मिलेगा बिटवीन द टू नॉन इक्वल प्रोटॉन, उतना स्ट्रांग कपलिंग कांस्टेंट होगा. और इंफॉर्मेशन मिलने के लिए जो कनेक्शन चाहिए वो इलेक्ट्रॉन क्लाउड होता है. सी, इसका मीनिंग ये है. व्हाट इज द मीनिंग? दैट द coupling constant is depend on what? The maximum electron cloud should be between the two coupling, the two protons which are under coupling effect. If there is less electron density around them, there will be less coupling. So what are the factors which decrease the density of electron around those protons which are in the coupling effect or in the circle of coupling effect? So let us take example now. See, for example, see this one. What is the coupling constant for transalkene? Yes. It's above 11 hertz. Okay, it is above 11 hertz.
Sir,
660.
180.
Above 11 hertz. The trans protons, they have 180 angle.
Yes, sir.
So therefore they goes to
J maximum.
J maximum. Now you see here what I did. Wow, what we did? What we done here? We have bring out the epoxidation here, isn't it? Right or wrong? Yes.
Yes, sir.
Protons are where trans. Now we have brought here the epoxidation. So oxygen is what?
Electronegative atom.
Electronegative atom. So now see these two protons which were coupling to each other, they are trans, isn't it? They are trans or not? Yes.
Yes, sir.
So the electronic cloud of pi bond. See here, the electronic density of pi bond which are helping them to couple and show the highest J value. Now is it there? No, it disappear. And one more extra point, electronegative atom is incorporated, it is installed there. So what is now effect of J values? See the effect.
J value reduces.
Highly reduction, yes. J value goes to the very much reduction, yes. It reduced to very what? Very low. You can see. Right? Yes. So now further, now see the epoxide have much smaller coupling constant because of three factors. देखिए हमने क्या किया, सेम मॉलिक्यूल को इपॉक्सिडेशन किया है, इट इज इपॉक्साइड एंड जे वैल्यू बहुत रिड्यूस हो गया है because of three factors. First factor is the carbon bond is longer. Now remember, here carbon single bond है कि double bond है इसमें?
Single bond.
And here
Single bond.
double bond.
Double
So
bond.
can you tell single bond is larger or double bond is larger?
Single bond is larger.
Single bond is larger and double bond is
Shorter.
shorter, right?
Shorter.
So single bond is larger,
Single bond.
single bond is longer or double bond is longer? Again one more
Single
chance.
bond is longer.
Single bond is longer. That is right. Single bond is
Yes.
longer. It is, we are learning this since a long time.
Single bond is longer.
Yes, this is longer. So what will happen when single bond is longer? So this H2 distance also increases. Therefore they are away from each other. So क्या होगा? Electron density दूर हो गई. Yes, right. Second reason, there is an electronegative atom. So oxygen becomes an electronegative atom. So what it will do? It will withdraw electron density, right? Yes. And what is the one more point? Spreading out effect. You see cyclopropane ring में protons are at maximum distance, right? Yes, because of and therefore goes to the minimum. These are three factors which decides the J values, and from J values one can find out the many information we can collect, right? Okay, right. So let us go for this example of furan, furfural. It is called as furfural. Apply this idea. Yes, Adil, Atik, apply the idea of sentence of the day and produce your answer in a sentence. Yes, Nikita Rani, bola.
Sir, proton attached to the oxygen have minimum J value.
Very good. Which proton? So this proton
attached to the oxygen.
You see
yellow wala sir.
Yellow wala. There are two yellow wala. So you tell 1 minute. See, I will number this for you people. I will number this. Don't worry. Suppose this is number 1, and this is number 2. So you tell which is having the lowest value of J.
Number sir, 1. Second one. Second
2
one.
sir.
2 or 1?
Sir, 2.
नहीं
two,
अभी
two, sir.
नहीं, 2 आवाज आ रहे हैं, तो मुझे बताइए. यस, कोई एक बताइए कि which is the correct answer. Yes, Saima, you tell. Saima.
Second वाला.
Second वाला. One first answer किसका है ये?
सर मेरा है.
Rumeza. So yes, Rumeza ना?
Yes sir.
So Rumeza, you see, ये इलेक्ट्रोनेगेटिव एटम जब आता है तो वैल्यू कम हो जाती है, मालूम हो आपको ये? तो ये इस कार्बन को क्या अटैच है? ऑक्सीजन अटैच है, इस कार्बन को वो अटैच है, इसलिए वो इलेक्ट्रॉन क्लाउड खींच लेता है.
और सिंगल बॉन्ड है.
तो ये कार्बन पे हाइड्रोजन है.
हाँ, तो सर नंबर 1 के अंदर जो है वो सिंगल बॉन्ड पे है ना, तो उसकी जे वैल्यू कम आएंगी.
कहाँ पे नंबर बॉन्ड, कहाँ पे बोल रहे हैं आप? ये सिंगल बॉन्ड
नहीं रुमेसा, ये सिस्टम एरोमेटिक है तो इलेक्ट्रॉन क्लाउड पूरे तरफ है, वो सिंगल और डबल बॉन्ड नहीं है, पार्शियल 1.5 बॉन्ड करेक्ट.
यस गॉट इट.
ये सब में दोनों में फिर जे वैल्यू बढ़ेगी.
जे बढ़ेगी नहीं, हमको सब फैक्टर्स
सर,
यहाँ
नहीं.
हाँ बोलो फायदा, गो अहेड बोलो.
बॉन्ड ऑर्डर है ना वो सब बॉन्ड की 1.5 है, तो उससे कुछ डिफरेंशिएट नहीं होगा। डिफरेंशिएट
Yes.
ऑक्सीजन जिसको अटैच है ना उससे होगा।
Very good.
ऑरेंज वाली को ऑक्सीजन अटैच है ना, तो इलेक्ट्रॉन डेंसिटी कम होगी और उसकी वजह से जे वैल्यू कम आएगी।
Very good. Very good. That's it. That's it. समझेगा फायदा अभी आप, सॉरी रुमेजा,
हाँ सर समझा।
समझना जरूरी है। आप बार बार पूछने का 10 बार 50 बार, नो प्रॉब्लम। सी सो नाउ you got it. So sentence of the day gives us the information. So you see what is a J 1.6 and it must go, sorry, what is that is 3.6. So you people got it. So see now the compound is given to you. ये तो आप ये स्लाइड देखकर बोल रहे होगी, लेकिन अगर आपको अलग सिस्टम से दे दिया जाए और मुझे बताओ आप, नाउ यू टेल मी, सपोज आई एम ड्राइंग स्ट्रक्चर हियर, नाउ सी गिव मी 2 minutes, no, only 1 minute, let me draw the structure and we will talk on that. Okay, we will talk on that. Fine. Now see, suppose I am having this structure now. I am having this structure now. Oh, sorry. So this is the structure. This is nitrogen, right? दिख रहा है सबको? Okay, now I want from you people. This is the hydrogen. Suppose this is the hydrogen. यहाँ पता है ना नाइट्रोजन है यहाँ पे? Yes, pyridine. And here suppose we have other groups like this, and here we have hydrogen. So why I have drawn here like this? Because our aim is to know about this hydrogen and this hydrogen coupling, okay, and this hydrogen coupling. So green with this red, red with this red. So yes, now which is having the lowest coupling constant?
Green with red.
Yes, Umeza, what is your answer?
सर ग्रीन विथ रेड, इसकी
Now
लोअर
you-
वैल्यू रहेंगी क्योंकि वो इलेक्ट्रोनेगेटिविटी के साथ अटैच है हाइड्रोजन।
Yes, that's great. Very good. So आप लोगों को समझ में आया सबको ये?
हाँ
Yes,
सर।
yes, fine. So this is what about this today's talk. So next topic would be about this. We'll move for very good structure now. That is what ये appear हो रहा है यहाँ पे ना।